Good morning, everybody. Thanks for joining Technical Training Aids and Matrix for our webinar this morning. Want to take just a second and introduce Liam Walton. He's the Managing Director of Matrix, a company that's based in the United Kingdom. He's going to present the electrical machines training program that Matrix has, highlight some of the other program areas that they cover, and talk about how these products could be used both in the classroom setting as well as doing some remote learning. Technical Training Aids is a local reseller for the Matrix product line here in the Southeast U.S. Just wanted to take a quick minute to remind everybody to mute your lines during the presentation. Liam will mute all the lines when he starts, and then we'll open everything back up at the end for Q&A. He's going to present for about 30 to 40 minutes, and that should leave us about 15 to 20 minutes for Q&A at the end. You can utilize your chat box to enter questions that we can log during the webinar. So, Liam, I'd like to have you go ahead and kick it off. We want to thank you for putting this presentation together today, and let's go ahead and get started.
Thank you, Travis. Thanks very much for the kind introduction. That was great, and thanks from myself and Matrix to Technical Training Aids for facilitating this webinar this morning. So I'm just going to, before we kick off, I'm just going to jump in and mute the lines for everyone. Okay, I believe now everyone else is muted, so we don't have any echo on the line or anything, but I do sincerely hope that you guys can still hear me well. So I'm just going to kick off the webinar by just giving you a little bit of an introduction to Matrix. So Matrix Technology Solutions, we are a company that has been in existence for 27 years. We're based in the United Kingdom. We were founded in 1993 and began our life creating content for CD-ROMs for the education sector. The internet kind of put paid to that side of the business, unfortunately, but it meant that we had to diversify a number of years ago. And that brought us through to today, where we now have hundreds of products offering hardware and software-based solutions for varied levels of technical education from high school right through to university level. We're based, as I say, in the United Kingdom in a small town called Halifax in West Yorkshire. We're privately owned, financially stable, professional and agile organisation. Our facility, which you can see on screen at the moment, is an 11,000 square foot facility comprising of our sales team, research and development, and manufacturing, which takes place here in the UK. Every year we spend over 25% of our turnover on research and development, and more than 90% of what we sell goes into the education sector, although we do have a number of industrial clients and customers that allow our products to be used in that environment, which is obviously really important for the education sector as well. We sell in more than 50 countries, and export accounts for more than 60% of our business now, and that's a growing number. We have 60 international agents, and TTA, Technical Training Aids, are one of our agents in the US market, a market in which we have a number. We have a range of products, and we cover various different disciplines, subject areas, and so on. So we have products for science, mainly for physics, computer science, fiber optics, optics and photonics, various strands of engineering, electrical and electronic, mechanical, robotics, mechatronics, manufacturing, and then we also have products for aviation, automotive, and electrical installation. You can find out much more about the whole range of products that we've got through our website, which is matrixtsl.com. and everything's broken down there into discipline areas or solution areas and into product ranges. So you can find out more about the full range of products that we've got on the website there. But what we're going to focus on today is we're going to focus on a product that is relatively new to us. We only launched our electrical machine system in 2019, and I want to talk to you about the system, about the benefits of it, about how we're seeing growing interest, and at the moment seeing growing interest for this product as a distance learning platform, where teachers can utilize its benefits for teaching students who are based in the home because of the challenges that we're obviously all facing at the moment. So the agenda that I would like to run through today is I'm going to talk a little bit about the challenges of teaching from home, which I'm sure many of you will already be familiar with, how this or these challenges impact on the teaching of topics such as electrical machines and other engineering disciplines. I'm then going to sort of run a demonstration of our electrical machine system, which I have in front of me here, show you how it works, and just talk a little bit about it. I'm going to talk you through what we have on offer in our electrical machine system, the main system benefits, how and why it can be used remotely to teach your students, particularly in the current climate and demands that the market has. I'm going to talk you through our various curriculums, of which there are 4, and then we'll finish by talking about the costs of our system and how that relates. As Travis mentioned, we will probably close with 15 to 20 minutes or so remaining of the webinar, where I'm happy to take any questions. If you've got questions throughout, I'm more than happy for you to pop them in the chat that's available to you, or I can unmute everyone at the end, and any questions can come through that way as well, and I'll do my best to answer all of those. Okay, so focusing on our electrical machines. Our electrical machines range is a revolutionary and modern way of safely studying the characteristics of different types of machines in a learning environment. So the range consists of 7 different types of machines. It also comes with 4 separate curriculum manuals, and I'll talk a little more about the curriculum manuals later on in the presentation. You can see on the screen there the system that we have on offer. It's a very compact system, and I'll talk a little more about the benefits of that in a little while. But as I mentioned here as well, this is a safe way of studying about modern electrical machine systems. So it can be, it's a system that runs on just 24-volt power, AC or DC. Therefore, it's extremely safe to be used. It's a portable system. It can be moved from lab to lab, or it can even be moved into the teacher's home if necessary for teaching this topic to students. On top of that, this is our fastest growing range of product. And as I mentioned, we did only launch this last year, 2019, but we already have a number of customers that are benefiting from the system itself. So that in terms of the challenges, I said I'd kick off by talking a little about the challenges that the current situation provides you with as teachers and lecturers. And I've just noted down a few of them here, and some of them might be sort of familiar to you. But trying to keep students' focus is particularly difficult at the moment. You know, they're doing a lot of theoretical work. You're planning a lot of theoretical work for them. It's not always easy to plan hands-on work and work that is traditionally required, necessary, and beneficial for people who are studying engineering disciplines. So student focus and keeping them engaged is a big challenge, particularly at the moment. Another challenge that faces teachers and lecturers right now is space. Space is obviously limited. Now that can be particularly when you're teaching remotely from your own home. It's not always the case that you've got lots of desk space like you would have, for example, in a classroom. On top of that, a lot of the equipment that's supplied into engineering labs in colleges, schools, universities and the likes, a lot of the equipment that's supplied is often big, bulky equipment that needs to be in a lab permanently, can't necessarily be moved from lab to lab. Maybe it's connected to the mains because the power voltage requires that. And so space proves a difficult challenge for you to overcome. As a result of the fact that we are all kind of doing this distance learning, distance teaching thing at the moment, accessibility of the equipment that's on offer to us is difficult as well. So it's difficult to get hold of a set of, say, electrical machines to teach about the characteristics of motors and machines to students. Experimentation, therefore, becomes difficult. Students need to be hands-on in any engineering discipline teaching. They can't just simply be taught theoretical work, in our eyes anyway, and then be expected to go into the real world and understand everything. And so experimentation provides a huge challenge. And of course, for teachers and lecturers, workload is often increased. More preparation is required. All of a sudden, all of your plans for the final month of the academic year have been turned on their head, and who knows for how much longer things are going to be different for us. The impact of all this can be felt by both teachers and lecturers and by students. So a lack of quality teaching resources for engineering, a lack of affordable teaching resources for engineering is really available at the moment as well. It's okay to go out there and resource or find e-learning platforms on which you can teach things via simulation, for example, but if we're honest, nothing really beats seeing a system actually working, seeing movement, in an engineering type scenario and things like that. There's obviously less hands-on possibilities for the students. That's a really difficult one to overcome, and away from the electrical machines range, which we're talking about today, Matrix, we have a range of affordable equipment in other areas of microcontroller study, of electronic and electrical engineering circuits, for example, that potentially give that hands-on capability back to the students at a time like this. Less experimentation is also taking place right now, and I've talked a little bit about that already. But all of this means that students are getting little real-world experience right now in comparison to what they would traditionally be getting. This can have a huge impact on future development and a huge impact on their understanding. Okay. Students often are able to come up with excuses right now as to why work hasn't been completed, why they're not understanding a particular subject area or something. And to be honest, that's going to happen in the current, scenario. But teachers can offer extensions, they can offer flexibility. However, what we feel is that having equipment that is A, affordable, and B, accessible to you, so it's not huge equipment connected to mains, taking up power, taking up space, that can be, it's equipment instead that can be taken home and utilized. We think this helps to eradicate this problem and helps for you to maintain some level of experimentation and hands-on learning for the students whilst they are at home. One of the other things that's challenging as well, and the impact, is that proof of task becomes difficult. Now, we have our electrical machine system here at the moment, which we're currently adapting and making changes to in order for it to have a connection, internet connection. Now, this would mean then that students can carry out experimentation remotely. They can be connected via a software environment to the electrical machines equipment that we have and perform experiments and see things working from their own home. Okay, so that's something that is on the on the horizon for us, but not too far in the future for this particular set of equipment, and that will enhance its capabilities for the current circumstances. So what I'm going to start off with in terms of a demonstration is I'm actually going to show this system running. Now, if I can just jump out of the presentation here just a second, I'm going to bring up instead the control environment that we have for the electrical machine system. So you'll be able to see that now on your screen. What I've got in front of me, let me just explain. And you'll see some photos in a few moments of what I have in front of me. On the desk in front of me, I have our electrical machines control box. Okay, the control box I'll come on to in a slide or two's time and explain what this control box consists of. But essentially, this has a connection to just a plug-top power supply, 24 volts power going into the back of the control box. We then have a connection from the control box into my laptop. That's just via a simple USB cable. And then we have a connection from the control box going into the dynamometer, okay, and the dynamometer I have on the desk next to the control box in front of me. Into the dynamometer, I have my DC motor, okay, so we're just going to run an experiment on the DC motor, and we're going to see some results appear on the screen. I have 4 leads connected. One is two of them are connecting up the DC power supply to the DC motor. That's from the control box into the DC motor, and then I have 2 leads that are connecting the control box into the dynamometer in order for me to be able to provide load if I wish to do that for the experiments that we conduct. So if we just start by you open up this environment. The environment that you see in front of you can be just downloaded from the Matrix website. Obviously, it's not capable of doing anything unless you have a set of the equipment. We hit the Run button, which is up in the top left corner of the screen, and then the connections light up in green. The only connection that is not yet green is the Run connection. So if I hit the Run button here, that will light up in green, and then I can increase the power being delivered to the motor. Okay, so I'll do that by switching turning the knob on here, and then we have some power going into our DC motor. The DC motor is now rotating. We can see some readings coming on the dials. So we've got the current that's flowing through. We've got the voltage reading there as well. We can increase using this dial here the load, okay, and see how that has an impact. We can see the speed that the motor's running at. So at the moment it's running at 730 RPM. That's reflected as well on the front of the control box with the readout that I have on there. And then we can see the torque that's being taken from the motor as well. What we then want to do is we want to perform a sweep. Okay, so we're running here at just 50% frequency or voltage on the machine. If I click on the sweep button here, okay, we will begin to plot a graph on the speed torque curve. Okay, I'm then going to just quickly move through to 60%. And we're going to see another curve on the graph. We're going to move through then to 70%, and we're going to see another curve. Faintly in the background, you may just be able to hear the motor rotating. I would hope that's not having any impact on my sound, because I have located it at the opposite side of the control box to the phone, but hopefully that's not providing any issues. This is the last one that we'll do now. So what you can see here is that we've created there a speed torque curve. If I just stop the motor, a speed torque curve for a DC motor running at various frequencies. Okay, that graph that we have there can then be taken as evidence by the students. So you can run a session in the way that I am now with the students and explain what you've got in front of you. You can use camera if it's necessary to show what you have, and you can run it like that. Or in the not too distant future, the student can connect to the system and they can actually run these experiments themselves and then take these results. The results can also be taken from here into Excel format as well. So if we just go over here on the side, so in the log file section here, you can see that the results are being put and thrown into an Excel document. Okay, so this Excel document then would allow students to manipulate the data and create the graphs themselves. Okay, this is the way that the students manipulate and control the machines. So there are 3 different types of software available, one for the DC motor, another for 3-phase motor, and then a separate software environment for the AC machines. And they are all downloadable freely from the Matrix website. Right, I'm going to skip back into the presentation because what I want to do now is just show you what was in front of me for that experiment. So another benefit of what we have with the Matrix electrical machine system is that it's easy to use. I mentioned what I have in front of me whilst I ran that demonstration. I have a control box. The control box can be seen underneath the laptop here. There's no particular reason why the laptop is located on top of the control box, but I guess what it does do is it gives you a good sense for the size. Okay, so it's not a huge piece of equipment. It's about the size of a laptop, albeit a little deeper. We then have a dynamometer. So the dynamometer sits on a bed here. Okay, onto that you slide the motor of choice. We'll go through the motors that are available in the range in the slides after this one. In terms of my experiment that I just ran, I had a DC motor. That runs in, it connects in to the dynamometer on the central spider here. Okay, so you've got a firm connection in place. You've then got switches which connect in the base, which means that the system will not run unless there's a clear connection. Okay, we then wire up the motor or the machine to the system itself, and that's just done using 4mm connectors. You have connections going from the dynamometer into the control box to provide load, and then you have connections from the motor itself into the control box. The user will then load the relevant program, and these, as I said earlier, are just downloaded from the Matrix website. And then finally, follow the worksheet of choice to run the readings and results that you get from the motor that you have in position. And again, we'll go through the curriculums in a moment or two. So this system is really easy to use, and as I said earlier, running on 24 volts AC or DC, it's low voltage, and therefore there are no safety concerns necessarily for teachers or students. So just to give you an idea of what's available in the range, the first thing that we have is the dynamometer, which is a long-shafted permanent magnet DC machine, free rotating between bearings, and this is mounted on a cradle. This side to the right of the dynamometer that you see is coupled to any of the machines available in the range, and they push together and house within a plastic tube, which ensures that no moving parts are accessible to the teacher or the student. On the outside of the dynamometer, there are 2 4mm shrouded safety connectors, which are used to add electrical load to the machines, as I mentioned, when using them as generators. The machine that I had in test for the demonstration just a moment or two ago was this 24-volt, 50-watt permanent magnet DC motor. This is our simplest machine and has 2 magnetic poles for the stator and wound rotor with carbon brushes. I'm just going to briefly introduce you to the full range of motors that are available. The next is this universal motor, which can be driven from 24 volts AC or 24 volt DC. Again, the connections are made via separate 4mm shrouded connectors, which you can just see on the outside here. There are 2 run rails underneath the base of the motor, which allow connection to the dynamometer. And then on the end here, you can see the spindle that connects in to the dyno. Okay. The next machine we have is a single phase 24 volt 35 watt induction motor. Again, similar in how it connects up to the control box and how it connects into the dynamometer. We have a shunt motor, which is a 24 volt device, works in a very similar way, and then we have a 3-phase motor, 24 volt 35 watt induction motor, and finally a particularly interesting motor, which is this much smaller brushless DC motor. The type of motor that we're seeing used in all sorts of industrial level applications at the moment, including electric vehicles, for example. And this particular motor has 24 volt 3-phase supply and Hall effect sensors, which allow sense of rotor positions. Okay. So that's just a quick introduction to the various machines that are available in the electrical machines range from Matrix. Which brings me on to the control box. So the control box is kind of the brain of the whole system. This has a whole host of features, and this is a hugely clever piece of equipment. It's small in size, as I said earlier, and this is really where our experience and expertise is really put. So the electrical machines control box allows for the user to select between DC, single-phase AC, and 3-phase AC outputs. It includes integrated voltage and current measurement, adjustable resistive loads for the dynamometer, which come from the purple sockets on the left side, and series winding resistor. It has switchable start and run capacitor, which comes from the yellow sockets on the far right of the control box. And in total, I think it's 14 different embedded instruments that are available from this control box, which is hugely impressive. On top of that, for the more advanced learners, the more advanced teachers amongst you, into here is embedded a unique API, an application programming interface, which allows connection to be made between our system and the MATLAB environment or the LABVIEW environment, which I know you guys, particularly teaching at the highest level, will be familiar and interested in. And lastly, as I mentioned enough times already, the footprint of this makes it small enough to sit on a desk along with the rest of the kit and the PC. I won't spend too much time talking about the PC software because I gave you a good feel for this earlier, but what I will mention is that there are 2 different ways that the software can be used. It can be used in a way to log the results of each individual machine, which is what I showed in the demonstration not so long ago. But it can also be used as a control environment and therefore to show traces on an oscilloscope, for example. So particularly when you're using machines such as the 3-phase machine, you can see the control software has an integrated oscilloscope to show the 3 phases on screen and you just really get that message across clearly to the students. You've got a whole host of gauges, dials, and readouts in there as well to give the results visually to the students. Okay? Now, everything that I've talked about so far has been about how our system can be used in a PC context. So how it can be used with connection to a PC, which is, in most scenarios, how people utilize the system. However, there is another way that the system can also be used, and that's in what we call manual operation. Okay? In manual operation or manual mode, the user can connect up multimeters, real, true RMS multimeters to the control box, and they can connect up their oscilloscope in order to take the readings that they need. Okay, these readings can then be used to follow some mathematics and calculate torque, calculate speed, and this type of thing that's coming from each individual machine. So it's not a case of the students having to work with a PC. They can work manually using this system. But as we're talking a little bit about how this system can be used as a distance learning tool, like I am doing right now for you guys, I just wanted to touch on the manual capabilities of it nearer the end of the presentation. Okay. I've mentioned briefly already the fact that there is MATLAB and LABVIEW support, and when I go through the curriculums, you'll see that particularly a couple of our curriculums are designed and written to give that kind of message across to you. So basically, we have a suite of API calls which are provided to you in the curriculums, and they allow this system to be used with MATLAB, for example. Students can then understand characterization of electromechanical systems using mathematical formulae. And we have some information on that, and when I come onto the curriculums in a few moments, I'll show you those examples. So just to conclude, before we look at the curriculum, the benefits of the system itself. So we split these down into practical, safety, and operational benefits. Practical benefits are that this system is small in terms of its footprint, and the machines are portable. The equipment is even supplied by us with stackable trays and boxes that it can be stored in and packed away at the end of a class, or even if it's at the moment being utilized in the teacher's home, for example. We offer the system as a complete system where all machines are provided, and we also offer it as a core system or a core set of equipment where only a handful of the motors are supplied, and I'll go through that in a few moments. Safety benefits: all moving parts are covered, safe operation for students operating the machines. It operates on 24-volt power, AC or DC, which means less danger for students, staff and technicians. And then there are a number of operational benefits. So users can measure voltage, current and power in DC and AC, easily create speed torque graphs. There are 60 hours of teaching across 4 curriculums, 7 different types of machine, including brushless, and the system can be utilized in PC or manual mode. So we kind of refer to that as virtual or analog instrumentation, which can be used on this system. So then I come on to the curriculums. I'm not necessarily going to read out all of the information here because there's a lot there to kind of go through and talk to you about. What I am planning on doing, or the guys at TTA are going to do, is to share this presentation with you afterwards. One of the huge benefits of working with Matrix is that we publish all of our curriculum up front, free of charge, on our website. It's not behind any login. It's not part of a package when you purchase from us or anything. It is just there as a PDF document that you can access and see everything that can be done with the systems. So there are 4 curriculums that exist for this particular set of equipment. And the first one is aimed at what we term as the 16 to 18-year-old market. So this would be curriculum that can be followed at the upper high school, maybe into the community college market. This teaches students the basics of electrical machine operation, speed torque characteristics, the relevant mathematical relationships such as torque, power and slip, and details of the circuits and power supplies needed to drive them. And so there's a whole range of worksheets here. I think there's 20 plus worksheets in this particular curriculum, and we can provide access to this, well, you can access this, should I say, without needing to ask. Just visit the website and it's there for you. The second curriculum we have available focuses on manual operation of the machines. Okay. Now, there are 2 separate markets that we've seen purposefully in terms of where we targeted for this equipment, but we've seen an engineering focus, and then we've also seen interest from what we call in the UK electrical installation. For you guys, I guess it's domestic wiring, commercial wiring, in more of a trades kind of kind of area than, you know, in engineering. And in this particular environment, students are more focused on paper exercises. So they actually need to, they're not particularly PC friendly, you know, kind of classes. So the students are taking manual readings, they're using instrumentation, analog instrumentation to take readings, and then they're plotting their own speed torque curves and things like that. So this is the second curriculum. The third curriculum focuses solely on MATLAB compatibility. So it presents how you use MATLAB to measure the characteristics of electrical machines using our system. And as I said earlier, a full application programming interface, API, is provided. The final curriculum is a curriculum that we are just launching right now. In fact, this is the final curriculum, which is what we term our advanced electrical machines. So this resource introduces students to more advanced concepts and models of electrical machines, and focuses particularly on building equivalent circuits. We have, alongside this, launched an add-on to the system, or we are in the process of, should I say, of launching an add-on to the system, which is an inexpensive locked rotor add-on, which can be added for experimentation of this type of subject for the more advanced learners studying within universities. So that's the 4 curriculums available. They're all free of charge. They're all accessible through our website, with the exception of the 4th there, which is currently just being finalised and will be up there very soon. So before we go on to the question and answer session, which I'm sure people will have some questions here, we'll just briefly talk about the pricing model for our system. So there are 2 options that users have. Option A is the full complete system. Everything is supplied here: the control box, the dynamometer, all of the machines, including the dyno itself, software and curriculum, which are downloadable for free anyway. And for this setup, it's $10,000 US. The second option is the core set. The core set comprises of the control box, the dynamometer, DC and 3-phase machines, along with software and curriculum. And this retails at $6,875 US. If option B is chosen, then individual machines can be added as and when required, and they are $1,000 US per machine for the brushless universal series, single phase and shunt. So in comparison to other offerings on the market, this system has a number of unique aspects, and particularly in the current climate that we find ourselves in, it's a system that can be utilized for distance learning because it can be taken anywhere by the teacher. You know, it's small enough to fit on a desktop in front of a PC or screen. It's a system that we are shortly going to have with internet connectivity. So in terms of a remote lab going into the future, that's something that we're almost there with now and going to be able to supply this with. The last slide in this presentation kind of just outlines potential lab suggestions for if you were interested in a lab of 12 sets of the equipment, 8 sets of the equipment, 4 sets of the equipment even. As you can see here, I'm not going to go through all of this, but the top section here introduces 12 sets. 12 sets of the full system would be $120,000 US, and then you've got the optional add-ons, which are the analog instruments as well, and then the bottom section of each table presents the core set, and the core set for 12 full systems would be $82,500 US, and then again you've got the optional instrumentation. And so then we have the 8 set and the 4 set options below. Of course, that kind of can be manipulated in any way you wish. You know, you're not stuck by those 4, 8s, and 12s or anything, but you just let the guys at TTA know, and I'm sure they'd be happy to help. So that concludes the presentation. I'm just going to unmute and people's mics so that we can take any questions if there are any.
Oh.
Okay, Travis, are you there? Are you happy with that? Is there anything you'd like me to cover that I've maybe missed?
Oh, I didn't even look at
No,
that.
you did a great job. Thanks, Liam. If you do have a question and you have muted yourself at the beginning of the call, feel free to unmute now. You can also enter in questions into the chat.
For the vegetarians. And mashed potatoes and...
I guess somebody's talking about dinner plans.
The medley that I make on the grill.
Yeah, if anyone does have any questions, I'm happy to stick around here for as long as it takes to answer any.
Did you get my picture last night?
Is there available for people, or verbally if people want to shout out and ask the question. I'm more than happy.
I saw the concrete guys over there the other day next door, and they were doing all the plumbing.
Sounds like Rob.
Hey, Rob. Rob Algie.
Other side,
mute yourself.
put all this new stuff in there. And
Yeah, that's definitely Rob Algie.
I went and talked to the guy the other
Hey,
day.
Liam, Scotty Weller here. I think I know the answer to this already, but if students wanted to look at the curriculum, they would just go to the website and they could grab the curriculum just like the instructor, correct?
Correct.
Correct, yes. That's exactly how it works, yeah.
Yes, how are connections made with the multimeter and oscilloscope to your power box?
Yeah, they're just made through 4mm connectors, 4mm leads, which are supplied with the system. And so they just connect up to the relevant oscilloscope and then into the control box.
Okay. So the only measurements you can take are the interconnections that you showed us between the control box, the voltage supplied to the armature of the motor, and so forth.
Yes, that's correct, yeah.
You can't go in and separately measure the field of the motor or any of those, what I would call embedded motor characteristics.
I don't believe that's possible, no, but what I'm going to do, I'm going to speak to a colleague of mine and just see if I can get some clarification on that. Could I just take your name? Do you mind? Sorry?
Not at all. My name is John Levy, L-E-V-Y.
Perfect. I'm sure that the guys at TTA will have your details because you've signed up, obviously, to the webinar. And so if I can get some answers on that particular question and come back to you separately, is that okay?
Oh, wonderful. Wonderful.
Do we have any more questions? Anyone else?
Liam, it's John Dobson here from Matrix. Do you want me to answer that one from John Levy whilst I'm here?
Oh, hi, John. Yep. Sorry, John is... I'll introduce you, John, first. Sorry, for anyone... and to Travis and the guys as well at TTA, you guys are on the line still. This is John Dobson. He's the owner of Matrix, and he's very familiar with the development of this particular equipment. So, John, yeah, if you want to answer John Levy's question there, I was just writing it down, but yeah, if you want to go ahead, that would be perfect.
Yeah. I think the answer to that, John, is no. You can't measure magnetic fields with any kind of magnetic field sensor, unfortunately, but it's a nice idea for maybe the future.
Okay, I'm a teacher at a 2-year technical college, and I teach this subject, motors and motor control, every year. So I'm pretty familiar with all of the experiments and kind of stuff that you're showing here. What do you have for troubleshooting, to demonstrate troubleshooting and teach troubleshooting?
That's not in this package, really. This is all about motor characteristics at, say, 16 to 18 and how the different motors connect. And then going forward, it's MATLAB and then the modeling of motors with an equivalent circuit. Having said that, we've got a lot of individual resistors, capacitors, and other things that can be added to the system to show faults. So if you wanted a bad earth or a bad connection or something like that, then you could easily make it up with these individual components from our electronics range, and you could then use it to show faults.
Okay, but standard industrial, I'm teaching students to become industrial technicians, to maintenance technicians, automation technicians for factories. And they need to understand motor overloads and tripped overloads and three-phase, loss of phase, all of those standard issues.
Yeah, no, that's not covered in these packs.
Do you have plans to add that?
You've got me thinking.
And John Levy, this is Travis with Technical Training Aids, and we can certainly do a follow-up with you after the call to discuss some other options that might fit that need. They wouldn't be quite as portable, as the offering that we have here from Matrix, but I think we've got some things that we can certainly discuss, after on a follow-up. That'd be great.
Please.
Thanks, John. Anybody else got any more questions? Anything else you'd like me to, myself or John, who is on the call, to discuss? I think Erin is from TTA is sharing the slides with everyone that I've just gone through, so they're accessible to everybody.
Yeah, she included it in the chat box, and then we'll also do a follow-up email out to everybody that was registered with the link to those slides as well.
Good.
Liam,
all right.
I guess you did such a good job covering all the topics and functions and features to answer everybody's questions. So we appreciate your time and efforts in putting all this together for us. Great job.
Yeah. No, thank you for facilitating. I'm not planning on leaving for a few minutes, but people, if everyone is finished, I will understand if people do wish to depart right now, but I'll stick around and make sure I'm the last one to leave. Okay?
That sounds great. Thanks everybody for joining. We hope you have a safe and good rest of your day.
Thanks everyone.